simplify the expression, leave the final answer in terms of the first power of cosine. So I have the quantity 1 minus cosine of 2 theta all squared minus sine squared of 2 theta. I'm going to start by distributing out the quantity 1 minus cosine of 2 theta squared. So 1 minus cosine of 2 theta times 1 minus cosine of 2 theta, and then minus sine squared 2 theta. So here we are going to have to distribute everything out. We can't just distribute an exponent. So what we're going to have is 1 minus cosine of 2 theta. So if we multiply the first terms, then the outer terms. Now the inner term is another copy of minus cosine 2 theta. And then the last terms are going to end up as positive cosine squared of 2 theta. And then we still have to bring down the minus sine squared of 2 theta. So I want us to notice here that our expression has so far two terms that have a trig function to a power of 2. So cosine squared 2 theta, sine squared 2 theta. Our goal is to leave the final answer in terms of the first power of cosine. So I do have two terms that are to the first power of cosine, and they can in fact be combined together. So I have 1 minus 2 copies of cosine of 2 theta. So these are like terms here. We can add the negative ones in front to get negative 2. And then I have plus cosine squared 2 theta minus sine squared 2 theta. Now from here, we might be thinking, well, I have cosine squared and sine squared, and if I want to get down to the first power, then I should use the power reducing formulas. And we could do that. That would absolutely work, but there's a better way. So if we recognize that we have the double angle identity for cosine here, we can actually make some shorter work of this. So I'm going to write that identity off to the side. So we know cosine of 2x is equal to cosine squared x minus sine squared x. So what we have over here is cosine squared 2 theta minus sine squared 2 theta. So in this identity, what's in the place of the x is the quantity 2 theta. So we're going to replace the x with a 2 theta. So this entire collection of two terms over here is going to condense down to cosine of 2 times 2 theta. And then I still have 1 minus 2 cosine of 2 theta in the front. So my final answer is 1 minus 2 cosine of 2 theta plus cosine of 4 theta. So we have taken our original expression and made it so that I only have the first power of cosine involved in each term. Once again, we want to simplify the expression, but this time we're going to leave our final answer in terms of the first power of sine. So right now we have the quantity cosine x minus sine x all squared. And you might be thinking, well, sine is only to the first power, but because we're going to square this whole quantity, we definitely have actually more than one term that's going to involve a trig function to a higher power. So let's start by expanding this out. So we have cosine x minus sine x times the quantity cosine x minus sine x. Don't fall into the trap. Again, I cannot just distribute an exponent over addition or subtraction. So when I multiply this all out, cosine times cosine is cosine squared x. Then outer and inner is going to be minus sine x times cosine x minus sine x times cosine x, which is going to combine together. These are like terms. And then last is plus sine squared x. So now what I'm going to go ahead and do is combine these like terms in the middle. So cosine squared x minus 2 copies of sine x cosine x plus sine squared x. Okay, so now what I'm going to focus on is the cosine squared x plus sine squared x. Now, even though they're not next to each other, that's okay. We can rewrite these terms so we can switch the places here if we want, so that we can see sine squared x plus cosine squared x is equal to 1. That's a Pythagorean identity. So we are able to eliminate the powers of that are higher than 1 here, so cosine squared and sine squared, by recognizing that identity. So those are going to become 1 minus 2 sine x cosine x. So we've gotten rid of, two issues here because we want to get everything down to the first power of sine. All right, well here I have a cosine that's to the first power. To get rid of this, what I want to recognize is that 2 sine x cosine x is exactly an identity, the double angle identity for sine. So I have 1 minus sine of 2x. So I know sine of 2x is 2 times sine x cosine x. So I'm using that in reverse. And now I have an expression that has only the first power of sine involved. So I use two identities, the double angle identity for sine and the Pythagorean identity, cosine squared x plus sine squared x is equal to 1.